with the course Introduction to Engineering Mechanics, Truss Analysis. I have been teaching in the field of engineering mechanics for over 27 years. I decided to develop this module for truss analysis because the subject of truss analysis can be one of the most difficult topics covered in statics. In this module, what I have done, I have developed a step-by-step approach for using both method of joints and method of sections that you will find it very easy to follow and use. I hope you'll enjoy it. What are truss structures? Let's present an overview of these type of structures that are the first type of structures that we study in the course Statics. Trusses are a very special or simple kind of structures or substructures that are used in buildings, bridges, and many other types of structures. What does characterize a truss structure, or how do we basically differentiate between a truss and other types of structures? The main characteristics of a truss structure are as follows. First of all, trusses are made of slender members that are all pin connected to each other, and they're only connected to each other at the ends. In other words, each member of a truss is connected to other members at the end of each member that are pin connected, and therefore, if you recall from the definition of two-force members, all members of a truss are two-force members. That means the forces can act only along the line connecting the two ends, and since the members of the truss are straight members, so the forces act along the member of the truss. Also, all external loads that act on the truss are assumed to be carried at the joints. Although this may sound physically, of course, not realistic, but that is the assumption we make. Even, for instance, the case that we have loads distributed over the truss, we basically model these loads in such a way that they're acting only at the joints. The third thing that you need to know about a truss is that trusses can be either a 2D structures or a 3D structures. Let's show you a few examples of typical truss structures. Trusses are very common in building bridges. For instance, this building, as you can see, is made of trusses or a long truss, and as you can see, all members are straight, connected at the two ends to each other. This is another type of a truss structure. Again, is a bridge with a very long span. This is also another bridge structure. As I said, it is very important to know that the connections, which is at the ends of the members, are such that the connection does not carry any significant internal moment. That's why we assume they are pin connection. Let me show you a few more examples of typical trusses. For instance, this is a space truss, a building that all the external skeleton are made of these truss structures. This is a power transmission structure that is made of spatial trusses or 3D trusses. This is a structure that is a roof structure made of a truss. This is a pedestrian bridge made of a simple truss. These are 3D trusses that are most probably used for transmission towers or other applications. This is a building. Again, you can see all these different truss elements that basically are combined together and build the main skeleton of this structure. And this is a roof structure. What is the objective in truss analysis? The main objective in a truss, given that it only has nodal loads, and all joints are pin connected are as follows. Let me first show you a physical model of a typical truss. This is a real physical truss modeling, and that's how we basically represent or demonstrate a truss structure. This is of course a 2D truss structure made of several elements. As you can see, the supports are pin connection or pin connected to the structure, and all members are only connected at the ends to each other, and the loads act only at the joints. Okay? The main objective of a truss analysis is to find the forces in each member of the truss. For instance, in all of these members of this truss. There are two approaches for truss analysis, depending on what the objectives are. Either we solve for all the force members, all the members in all basically forces in all members. This is usually the case when you're designing a truss from scratch. For instance, you want to build a roof truss and you want to know how much force each member of this structure that you're planning to design will carry. This approach is called the method of joints. However, there are cases that you have an existing truss and for some reason, for instance, you're interested in finding forces in a few members. This is the case, for instance, that some of the members have deteriorated and you only want to replace those few members. You don't need to analyze the truss and find all member forces, but you only are interested in those members that you want to replace. This approach is called the method of sections. In the following lectures, I will be describing each of these two methods, and then I will be presenting through some examples how we can use these two different techniques to solve for the member forces in each truss structure. Thank you.